Not here today. All right, folks, go sit down. Okay, we're doing something new. Not right this second. Okay, we're doing something new. Okay. So you've got a piece of paper out so you can write something down. And you are going to write down what you remember of the rule for adding and subtracting with sig figs. This is what we learned yesterday. Let's see if what you remember. So write down what you think is the rule. And if you have no idea, then have a chat with your neighbor.
That's that one. It's that one.
So what is the rule for adding and subtracting with sig figs? You got my back, man. Awesome. All right. I'll give you a clue. Round to the what? First. Uncertain digit, yes. Okay, and we're going to do just a couple of examples because we didn't do any subtraction yesterday. So I'm going to give you an example with subtraction, just so that we can take a look at that. Let's say we have 14.3 minus 7.15. Okay, 14.3 minus 7.15. Remember, what you want to do is you want to circle or underline. I like circling, but you can underline or highlight. Circle the uncertain digits. We have uncertainty in the 0.1 position. We have uncertainty in the 0.01 position. So when we do our calculation, and I am going to use a calculator for that because I am not smart enough to do that in my head, although maybe I am in this instance, but I'm not going to trust myself. Minus 7.15 equals, hang on, 14.3 minus 7. It is 7.15, isn't it? That's a stupid number to have chosen because it's the same as before. But that's okay. It's fine. It's fine. It's fine. It does equal 7.15. I happen to pick the halfway value. That's fine. It's okay. But we do know that this 5, the uncertainty makes that hundredths position uncertain there. Okay? And we know that this 3 makes this digit also uncertain. Yes? And what that means, how many uncertain digits are we allowed to have? Just 1. So we're going to round off right there. So we look to the right of the 1 and we say that is a 5. So we're going to have to round up, and that's going to become 7.2. And our uncertain digit is here. Okay? Now, sometimes people, once they learn multiplying and dividing rule, which we will learn today, get upset by this because we started with how many sig figs in 14.3? 3 sig figs. And how many sig figs in 7.15? 3 sig figs. How many sig figs in our answer? 2 sig figs. So I want you to remember, with adding and subtracting, you can end up with more or less sig figs than you started with, okay? With adding and subtracting, you can end up with more sig figs or less sig figs than you started with. So it doesn't matter if you start with 4 sig figs and 2 sig figs and you get 2 sig figs, that's okay. That's okay. Okay. And let's see, did I give any other examples in my other block? Let me just check. Nope. So for now, what you're going to do is you're going to go to page 17. Okay, I assigned numbers 1 through 3 for homework, but if you didn't do them, now is going to be your chance. You're going to finish as much as you can of page 17. Okay? And I'm going to come around and check on you and see how you're doing with it. If you have confusion about it, now is a perfect time to ask. Okay? Yes. Let me find out. Hania, did you want to redo those quizzes now? Yeah? Okay. Do you want to bring them up so I know which ones? Okay, so measuring. Basic scientific notation measurement. There we go. So you need accuracy and precision. Yes. Okay, so we're going to give you one. This is basically the same as this one. Okay, it's just a different format. Counting sig figs. Form B. There we go. And accuracy and precision. Okay, I'm going to print one out and get it to you because I'm going to put one right here. Hello.
Am I able to write the one I missed yesterday?
Yes. Well, I gave you the wrong one. I gave you the wrong one for that. Was that the same as the other one? You want to do it? Oh, you already did it. So you're doing it for the first time. Gotcha. Let's grab you that one, which is exact and inexact. Form A.
It's pretty easy.
I hope so.
Where did I put them?
You can just ask him.
It's whispering.
Why don't you work on that for a minute and I'll find it, okay? Hi.
Do you want us to do it like this? Show you the actual answer?
You don't have to show me the work, but you need to give the actual answer.
No. You want us
Oh
to
yeah,
use
arrow, not equals, yes. Yes. Hi. Yes, that's on scientific notation.
Yeah.
I will find that for you. Scientific notation. Form B is or there we go. Okay. Did I do those? Are you not here?
We retake this one.
Yes.
Oh, and you got
You wanted to retake it as well?
Yeah.
There you go. Okay. And that would be in my bag probably.
Except one I got and four.
Just give me 1 second here.
Okay.
Okay, that's the one we just did? Okay, there we go. Just gonna pause this for a second. Just give me 1 second. So, I'm not gonna have Tyler teach this to us, but I will use his examples. That's really ugly. There we go. Okay.
Just connect with the Spanish.
That's okay, that's okay, that's okay. If nothing else, if I can't understand it, then I know that, either. What's your name? I don't know. Anyway.
Okay, thanks. Yeah, so put it in Spanish.
Perfect.
The English one is not correct.
Perfect,
I don't
perfect.
know.
Okay. All right. So here we go. So for multiplying and dividing, this is on page 18. Okay. We have, this is page 18. And if you've already done this in physics, you can just go ahead and do pages 21 to 23. For multiplying and dividing, what we do is we say I've got the number 62, which has 2 sig figs. I have the number 41, which has 2 sig figs. If I throw that into my calculator, I get this horrible, ugly number. 1.512195122. And you might say to yourself, hang on, I don't want to write that number. I want to write a reasonable number of digits, yes? Okay, so you might say, teacher, Miss Spence, how many digits should I write? But I won't have to tell you because there is a rule for this, okay? Can you guess how many sig figs I would like in your answer just from looking at what we've got so far? 2. Okay, so what we're going to do is we're going to say, I have 1, 2. There, we've underlined them. Okay, 1, 2. And we now need to do a rounding. And so we look to the right and we say that is a 1. So this number will stay as a 5. So it's going to be 1.5. All right. Next example. 782. How many sig figs? 3. 231. How many sig figs? 231. How many? 3. And we plug that into our calculator. We get 3.38528. But we will want to have how many sig figs in our answer? We started with 3 and we have another 3. So we're going to want 3 sig figs. Up here, we started with 2 and we had another 2. And so we wanted to have 2 sig figs in our answer. So we go 1, 2, 3. That's 3 digits. We're going to cut off there. We look to the right. That's a 5. So in this case, it's going to round up. And we will get 3.39 is good. Okay. Now, we are not going to do the next couple because it's basically just the same thing where we have a 4 and a 4, 4 sig figs, 4 sig figs. How many should we have in our answer? We should have 4 sig figs. So that would be 1, 2, 3, 4. We look to the right and that becomes 0.352. 2, 1. So it doesn't matter whether you're multiplying or whether you're dividing. That's how it works. We good with that? Here we go. We're now moving on to page 19. Oh, what happens if they're not the same? So now we have two that are not the same. Here we have 5 sig figs, and we have 2 sig figs. Yes? Should we have 5? Should we have 2? Maybe we should combine them and have 7. Well, let's think about this a little bit. The number of sig figs tells us how precise a number is, yes? Okay, so the more digits we have, the more precise. So this number is more precise than the 2 sig fig number. Yes, the 5 sig figs is more precise than the 2 sig figs. My answer is coming from a number that has 5 sig figs of precision and 2 sig figs of precision. My answer, can it have more precision than the 97? Does it make sense for my answer, which came from 2 sig figs, to have more precision than that? No. And that's the reason why we round to the smaller number of sig figs. So we look at this and we say, this is the smaller number of sig figs. All right. And that means that over here, we're going to round this to 2 sig figs. So we say, where is my 2? Well, I've got a 6 and a 4, and I'm going to stop there. I'm going to look to the right. That's an 8. So I'm going to have a 6, and the 4 becomes a 5. And then I have to say, this is the 600, so it has to be 650. Okay. Next one, 4 sig figs, 3 sig figs. So according to that, we have to find the smaller number of sig figs. Which is the smaller number of sig figs? 3. So we're going to, this is our smaller number of sig figs. And that means that this one is also going to be rounded to 3 sig figs. Okay, so that's going to be 1, 2, 3. Now I'm actually going to write this underneath because I'm going to round off here. So I look to the right, that's a 9. So we keep the 5, we keep the 0. This becomes a 2, and then everybody else up until the decimal place, which we don't really have, but you know it's there even if we don't write it, yes? Yeah? Okay, so we're going to fill in the zeros. Okay, so we have 502, 0, 0, 0, 0. Good with that? All right. So I'm actually on our little notes that we took earlier, if you were taking those notes, we're going to go and we're going to say, here is our rule for adding and subtracting is to round to the first uncertain digit. But the rule for multiplying and dividing is it round to the first uncertain digit? No. It is round to the smallest number of sig figs. Okay? So adding and subtracting is all about the uncertain digit. Multiplying and dividing is all about the number of sig figs. And the trick is that you need to remember both rules. This is the hardest part for most students, is just saying there are two rules and I need to remember when to use which one. And later on in the course, we spend so much time multiplying and dividing that you forget all about the adding and subtracting one, which is why I started with adding and subtracting, so that at least it would stick in your head for a little while. Okay, so we have two rules for that. I'll be happy to print this out for you. I guess I could put an example here, just so we have an example. Let's do something with some zeros in it. This is good review for your test on Friday, right? Because you need to say, this is multiplying and dividing, so I'm not concerned about the uncertain digit. Now I'm concerned about the sig figs. So how many sig figs in 0.00030? 2, because remember, zeros on the left are no, NYM, no, yes, maybe. Zeros on the left are no. Zeros on the right are maybe. And then we also have some zeros in the middle, which are Y. So those ones are yes. So what does the maybe depend upon? Yes? If there's a decimal or not. So if we say decimal, yes. Significant, yes. So how many sig figs in 0.00030? 2. How many in, over here we've got maybe. We say decimal, no. Is that one significant? No. Significant? No. So how many sig figs in this number? 1, 2, 3, 4, 5 sig figs. 0.0003 times 10080 equals 3.024. Now we're going to take that number, and remember, when you round, rather than putting an equal sign, you're going to put an arrow, and we're going to round it to the smaller number of sig figs. So we want to round this to 2 sig figs. We look to the right, that is a 2, so this becomes 3.0. Is good? Okay. So now you have all the tools in your toolkit that you need to do this stuff here. Okay? And if you decide you want to work ahead past that, you're welcome to. I can help you out with it if you want to. We're also going to do something else in about 15 minutes. There's one last thing we'll do, but we'll leave that for just now so you can be working on those. Okay.
Did I get a copy of yours?
Yeah, I'm going to. So now we are looking at multiplying and dividing in scientific notation. So today we are going to do it without using the special button on your calculator. If you have a calculator, I would actually like you to look on your calculator right now and see if you have a button that says EXPEE or times 10 to the X. Look on your calculator right now and see if you have one. If you do not have any of those buttons, then call me over and I'll tell you if you need to get a new calculator. Okay? Kasumi, I think you need a new calculator. Yeah. Okay? All right, but we don't need it today. All right, we don't need it today. What we're going to do is we're going to take advantage of the fact that if you have A times B times C, that is the same as C times A times B, which is the same as, you can put them in any order you want to, yes? Right? Doesn't matter. Yes? So if I have two numbers that are in scientific notation, like these ones here, everything is multiplied together. Multiplied, multiplied, multiplied. Yes, everything is multiplied. So I can put them in whatever order I want to. So what I'm going to do is I'm going to take my two mantissas, the two coefficients, and I'm going to put them first. Okay, so I'm going to take my coefficient 3.42 and 4.67, and I'm going to multiply them together to give me 15.97. So far, so good? Okay. The next thing we're going to do requires us to know a little bit about exponents. So, if I was to say to you, 3 to the 2 times 3 to the 4 equals 3 to the 6. When we multiply, what do we do with exponents? We add them, okay? I think it says that up here somewhere. Add the exponents to get the power of 10. So here we have our powers of 10. We have 10 to the 5 and 10 to the 9. So 10 to the 5 times 10 to the 9, that's going to give us 10 to the 5 plus 9, which is 10 to the 14. So far, so good? That is this part of the number. That's our power of 10, power of 10, power of 10. Now we're going to put them together. We're going to say my coefficient is 15.97, and my power of 10 is times 10 to the 14. Okay? Is that number in scientific notation? No, you have to check, because when you do it this way, you might end up with something like this, which is, of course, our no-no notation. Good review for Friday's test, because we're going to turn it into scientific notation. We need to have, why is this not in scientific notation? How many numbers should be in front of the decimal? We need only one digit in front of the decimal. So we're going to take this decimal and move it over one place. That gives us 1.597. So the 15 became 1.5. Did that get bigger or smaller? That got, well, is 15 bigger than 1, or is 1 bigger than 15? We have, let me grab a pen here. We turned from 15 to 1.5. So as we go from 15 to 1.5, did that number get bigger or smaller? 1 is bigger than 15? Smaller. We got smaller by 10 to the 1 power of 10. We moved the decimal place one place. That means that the other half of the number has to get bigger by 10 to the 1. So we go from 10 to the 14 to 10 to the 15. All right? And wouldn't it be nice if we were done? But remember, we're doing sig figs here. And this is a multiplication question. So are we looking at the uncertain digit, or are we looking at the number of sig figs? Number of sig figs. So we go back to our question and we say, in my coefficients, I had 3 sig figs and 3 sig figs. So how many sig figs should we have in our answer? 3. So we go back down here and we say, I should have 3 sig figs in my answer, 1, 2, 3. I look to the right, that is a 7 beside the 9. That means that a 9 is going to round up. So instead of 1.59, we will end up with 1.60. And that is our final answer for that one. Is that good? Okay. I need to fix this one. Our next example should say 2.93. That shouldn't be 3.93, it should be 2.93. And this number is just wrong altogether. This should be 8.3 times 10 to the negative 5. Okay. Pardon me? I need to fix it for the next version of this workbook. Oh, it is fixed for you. Oh, I've fixed it, but I copied. Okay, I know what happened. Okay, all good. So now we have 2.93. We're going to take once again, our coefficients, and we'll multiply the coefficients, 2.93 times 8.3, and we get 24.319. Our exponents, we have 10 to the negative 2, and we have 10 to the heck is that? 10 to the negative 5. So that's going to give us 10 to the negative 2 plus negative 5. So that's going to give us 10 to the negative 7. So we have 10 to the negative 7. That goes there. We have our coefficient. That goes there. And wouldn't it be nice if we were done? But we're not. What's the first thing we should look at? Or one of the things we should look at? Are we in scientific notation? Are we in scientific notation? No. So we're going to move this decimal place 1 place to the left. This number did it get bigger or smaller? 24 became 2.
Oh, the number or
the number?
Oh, the number goes.
The number got smaller by 10 to the 1, and so the exponent needs to get bigger by 10 to the 1. So instead of having 10 to the negative 7, we will have 10 to the negative 6. We also need to say, do we have correct sig figs? So you need to be thinking about scientific notation and sig figs. So this was multiplication. So we are looking at the number of sig figs in the question. We had 2 sig figs and 3 sig figs. So our answer should have how many? 2. So we look here and we say that's 2 sig figs right there. We look to the right and that is a 3. So we leave it at 2.4 times 10 to the negative 6. One more example, because we want to do division as well. The only thing different about division is, of course, you are going to divide your coefficients. So 8 divided by 2 is 4. But you also need to know what to do with the exponents. If I said 3 to the 6 divided by 3 to the 2, what would that equal? 3 to the 3 to the 6 divided by 3 to the 2. What do we do with exponents when we divide? We subtract them. So it would be 6 minus 2. So that would be 3 to the 4. What if we had 3 to the negative 4 divided by 3 to the negative 2? That would be 3 to the negative 4 minus negative 2, which is plus 2. So that would be 3 to the negative 2. It's the same thing, except for here you subtract, multiplying you add them. Here you subtract them. So same thing. Over here we have 10 to the 3 divided by 10 to the 2. So that's going to be 10 to the negative 3 minus negative 2. Sorry, that should be a 2. And that gives us 10 to the what? Negative 1. So now we have 4. 8 divided by 2 is equal to 4. There's our 4. And we have 10 to the negative 1. So we have 4 times 10 to the negative 1. You need to now ask yourselves, is it in scientific notation? Yes. Does it have the correct number of sig figs? Let's look. We have here, how many sig figs? 2. And how many here? 3. So our answer should have 2 sig figs, which means we need to add that extra 0.0. Okay? No homework related to this. Your homework is to complete pages 17 and 21 to 23, and also to study for your test. Okay? And bring a calculator, a scientific calculator tomorrow. And if you borrowed a calculator from me today, please bring it back. I lent out 3 of them.
I actually think from some.
Oh, that's
teacher's
okay.
class, but you can keep
Oh,
going.
thank you.
Yeah.
There we go.
Yeah.
That's helpful. Thank you.
Actually, no. Then your work hard. Only when he sees
What is wrong with me?
Oh, works real hard.
No, you're. What's wrong with me? I have no idea. Why is this exact? In a conversion where you're within one measuring system, so these are both imperial, both numbers will be exact. So if you're going metric to metric, both numbers are exact. If you're going imperial into imperial, both numbers are exact. If you're going between 2 measuring systems, the one is exact and the decimal number is not. Okay? Yeah. Yeah, that was yeah. Huh? Because of that 0.5.
Oh, okay.
See ya.
Hey, Eric. I'm